The moderator for this session is Ross Davies, who for some of you won't need any introduction, but Ross is the chair of our materials working group when he's not doing his other 11 hats. So I'm going to hand over to Ross, and then we're going to throw to a video. So I'll hand over to Ross.
Yeah, don't go away, Hayley, don't go away. Because I thought, this was a challenge. I thought it might have been like the Academy Awards. Have you got the envelopes or...? No, they're all winners. That's pretty disappointing, isn't it? They're all winners. We don't like it when there's all winners. I mean, I was thinking, David, stop playing with your thing. I thought you might be able to channel your inner Donald Trump and we could have like a version of The Apprentice. Oh, no, well, I forgot, of course, you're a gentleman. The other one isn't. Shark Tank is the other thing, but maybe a bit close with, what's happened on the North Coast. Maybe that one... No, maybe we mightn't go there. So no prizes. I'm really disappointed, but look, maybe we can do this as a double act thing, so we should introduce them. But firstly, I think we've got Michael Chin from, who's the asset manager for Main Roads WA, but he's coming via video. So standing in as the puppet in his place, that's how Hayley described him, is Louis Bettini. So Louis, very nice, but you should have the little Michael mask on, I think, really. So you've got 5 minutes each, and then I'm going to be really abusive. I got the easiest job of the afternoon. So you've got 5 minutes each. The video guy gets to cheat. After that, I start throwing the water bottles at you. Okay, shall we start? Okay, roll the video.
Our suppliers and designers were challenged to provide a better sustainable outcome with how we plan and reuse existing materials. I'd like to say this was an easy process. This wasn't a particularly easy process, as we were challenged to monetize tasks. A sustainable outcome I liken to innovation can be coined as an attempt to encourage the reader to look outwards into the world rather than inwards. The public's focus is often on capturing carbon-friendly large-scale capital projects in the $100 million plus category. These are ribbon-cutting events, but what about the impact to ongoing maintenance costs? A larger cost, often ignored with a larger carbon footprint. We discovered by making minor changes to how we plan and reuse materials, there was an incredible opportunity to innovate our future infrastructure projects for big dollar gains from relatively small type road treatments. Which is why we are here today proposing use of a common road marking material, line marking. We're combining this with new technology and changes to product design. The concept is to swap the currently used waterborne line with cold applied plastic line, or CAP. With CAP, the product life is predicted to be 6 times greater than waterborne. So rather than mark roads every year, why not once every 6 years? Within the Perth metropolitan network, with 1,200 kilometres of roads, this equates to 20,000 kilometres of line marking. CAP's advantage is it enhances existing lines, allowing the reuse of existing lines, therefore saving removal costs. So what are our sustainable savings in changing the way we mark our roads? By swapping to CAP material, the equipment used to spray CAP line marking equates to a saving of 606,000 litres of diesel, or 271 tonne of carbon emissions per year. However, with our materials in WA freighted in from Australia's eastern coast, once we add the shipping cost to transport material to Perth, the fuel saving increases to 7.1 million litres, or 3,170 tonne of carbon emissions saved per year. Now this doesn't include the fuel of delayed public traffic, or frustration associated with remarking lines, nor the improved safety or reduced maintenance cost. Also, we save 200 tonne of line marking material for the Perth metropolitan area over 6 years using cold applied plastic. So when we add in also the potential crash cost saving using willingness to pay approach, preventing killed, seriously injuries occurring, there is a potential saving available of $179 million. Now in closing, what other opportunities do we receive? With a change in product design, we get improved safety. There's clear, better nighttime visibility using a spot design. And combined with driving in wet conditions, there's improved surface drainage, with a change in design going from a flat to spot surface line, where visibility is important, which anyone in our Sydney and Melbourne states can confirm with your long winter and cold temperatures compared to Perth's. There's lower consumption of solvent. There's also no heating elements required, which will minimise your burns and eliminate additional fuel use. So there's a saving there. And also reduce cleaning work of equipment. And this leads to greater efficiency. Now, what's occurring overseas? Well, our overseas research indicates comparing available line markings indicates the most environmentally friendly solution is CAB, with the lowest carbon footprint. Now, this study was performed by Dr. Alexander Klein. Now, he looked at water, thermoplastic, cap and solvent lines. So how serious are main roads, or is this merely a flag-waving exercise? We will commence in November the first large-scale 6-year research trial on freeway standard roads comparing materials that will consider how changes in decisions can lead to better sustainable outcomes. Thank you for your interest.
Yeah, we've got the clapometer, so we'll use that to score people. Okay, so I think we'll go to Kate Harris now, and I'll pass you the little... All right, you can nick off now. Thanks. Yeah. Well, we haven't got any prizes.
Okay,
you know,
fear
really.
of Donald Trump. So I just want to confirm that, yes, materials, number one, do matter, but there is also a real challenge. I hear the challenge around the supply and the demand dilemma all the time. So I'm coming from a perspective of speaking on behalf of a lot of those manufacturers. Good Environmental Choice Australia is the Type 1 Independent 14,024 eco-label. And I'm just back from a global conference with many countries around the world with the same dilemma. But today we want to talk about concrete solutions of concrete. And I'm actually speaking on behalf of one of our licensees who's had a certified product for many years with GECA, as we're affectionately known, which is with independent cement and lime. And James Howard is here somewhere. So if you throw your hand up so we can all pester you later, James is over there. So I guess the message really today in 5 minutes is quite brief, is that there are already existing solutions. It's a call for more innovative designs for sustainable production and consumption solutions. We're very committed to SDG 12 and see infrastructure as a huge component of that. And if you have a look at cement and concrete being 5% of the world's CO2 emissions, that's no small figure and leaves a big opportunity for infrastructure to respond and do something about it. So in regards to independent cement and lime, they've really been leading the way for a long time and have blended cement options with solving things like even some of the waste issues with fly ash. So not only are we getting rid of a waste problem, but we're also having a sustainable product with sometimes up to 40% less cement with a blended cement option. And thirdly, as well as a sustainable outcome, often a very fit for purpose and often a hard manicured cement. But if you want more on the technicalities, James, your man. So really the message here is it's already here. We can keep innovating. We do need to move on green materials. There's a big demand in China, in India, Indonesia that are looking to Australia for those materials. But suppliers here, there are solutions that already exist that do create sustainable solutions, such as independent cement and lime, who are leading ahead in the benchmark of working with at least a 30% replacement with recycled materials such as fly ash. So we're encouraging everyone to continue the growth of the demand of that, particularly when it's ideal for infrastructure projects and it's fit for purpose. And it's an exciting way to reduce our greenhouse gas emissions. So yes, congratulations to Melbourne Metro, who was saying about reducing the actual need for concrete, but also let's reduce the amount of cement that actually goes into that as well. Thank you.
All right, let's hear that applause-ometer. Very good, thanks. Look, I think that's about even, but mind you, you were competing with someone who wasn't even in the room. So we'll just keep going. So the next one is Brett Jenkins, who's the Technical Director for Mott MacDonald. So.
Thank you. Whoops, is this working? There we go. Thank you. Yes, I'm from Mott MacDonald, but today I'm presenting on behalf of the T2T Alliance in Adelaide, for which I was the Structures Design Lead. And it's my pleasure to present to you today the innovative soil nail solution developed by the Alliance, which resulted in significant material and cost savings over more conventional retaining solutions. So just a bit of background about the project itself. The T2T project is an approximately 4-kilometre motorway standard upgrade to South Road, which is Adelaide's primary north-south corridor. The project incorporates about 3 kilometres of lowered motorway, so obviously finding a efficient and low-cost retaining wall solution was critical to the success of the project. So here's our scenario A and scenario B that Hayley mentioned before. So on the left-hand side, you can see the piled wall that was part of the 5% reference design. And on the right-hand side is the soil nail wall solution developed by the Alliance. So just a little bit of background about the reference design. Incorporated large diameter piles, 900 to 1200 millimetres in diameter at about 1.5 to 2 metre centres. So following the release of the reference design, the pathway to our revised solution was really kick-started by Richard Harriman, Principal Geotechnical Engineer from the Department of Planning, Transport and Infrastructure in Adelaide, or DPTI, as I'll refer to them. So Richard and his team have had a long-held view that retaining walls in Adelaide were overly conservative. They hadn't taken into account the inherent strength in the stiff Adelaide clays, and they really wanted they were keen for an alternative approach. So due to a lack of prior research, DPTI really took it on themselves and they conducted a trial pile wall using smaller piles than those proposed in the reference design. So the test wall was then subjected to a number of extreme load cases, for example, flooding the wall behind it to basically replicate extreme wetting that may exist from a burst pipe. And the pile wall was then monitored for a number of months to really accurately assess the in-service behaviour of the wall. A computer model was then generated and calibrated against the results of the trial wall. So all in all, the trial went very successfully, and the outcome was DPTI developed an alternative design rules for the design of retaining walls in unsaturated clays, which really reflect that the shear strength of the clays is largely governed by soil suction. So following this, details of the trial pile wall study, a revised 25% design for the project developed by DPTI, and the revised design rules were then provided to the tenderers for the T2T project. So then during the procurement, we entered the procurement phase, and during the bid and delivery phase of the project, the T2T Alliance then took this a step further and amended the revised design rules to be applicable to soil nails. So for those of you that don't know, a soil nail wall consists of a grid of steel reinforcing bars cored into an excavated face and then grouted, and then there's a protective shotcrete facing to hold the soil back. So that's the image that's on the screen on the right. So simplistically, in a pile wall solution, you're trying to hold the soil up, whereas in a soil nail solution, you take advantage of the strength of the soil itself and you're creating a reinforced soil block. So although soil nails have been used extensively in Adelaide before, they were for the old design rules, and they typically have quite closely spaced nails in the order of 1.5 to 2 metre centres, have thick shotcrete, 150 millimetres thick and conventionally reinforced. After an exhaustive amount of design effort and a rigorous independent review, our revised approach resulted in a solution having nails at 2 to 3 metre centres, and also incorporated a much thinner 75 millimetre thick fibre reinforced shotcrete facing without conventional reinforcing. So the reduced shotcrete thickness was possible as we developed an alternative design approach which allowed the nails to slip slightly under load, under swelling load, hence relieving any design pressure on the shotcrete. So really here's a summary of the material savings from the final design as opposed to the reference design. For comparison purposes, similar structural elements common to both solutions, such as architectural facades, traffic barriers, etc., have been ignored from material quantities. So you can see here there was an 87% reduction in total tonnes of concrete, and then this flowed through to be a 98% reduction in total tonnes of steel reinforcement. And this essentially reflects that piled solutions have quite heavy reinforcement, whereas the soil nail solution only has reinforcement locally in the nails themselves and at the nail head locations. So then from the materials calculated, this resulted in a reduction in 93% in total tonnes of carbon dioxide. And then, not surprisingly, this has had significant capital cost savings to the project in the order of $26 million between the reference design and the final design. So just to summarise, there are obviously a huge number of social benefits and legacy items. So the soil nail wall solution reduced construction time of the retaining wall itself by 312 days, and then this flowed through to reduce the overall construction program by about 9 days. Soil nailing is a lot less noisy and a lot less obtrusive than piling, and as the excavation progresses, the soil nailing occurs below ground level, and you essentially have the cut face which acts as a noise barrier. The revised design rules have now been adopted as DPTI standard, and they're being used on the Darlington project at present, and they're being applied to both piled retaining walls and soil nail walls there. And also worth noting that there's 15 kilometres of this corridor yet to be upgraded. The design approach is transferable to other regions where similar soil and climatic conditions exist. And finally, this revised design approach is being presented to industry through a full-day seminar by the Australian Geomechanics Society and Engineers Australia in Adelaide. So this seminar incorporated a number of worked examples, so this has left a great legacy to the industry.
Thanks very much, Brett. Next we have Rob Kilgour, the Materials Technology Principal Engineer for WSP Parkins Brinckerhoff.
Is it working? Yep. Okay, so we've been looking at a number of different bridge replacement options for a number of clients in Western Australia, and our bridge team have been exploring the use of weathering steel versus galvanised steel for replacement of primary bridge components. So in the business as usual case, we might go and fabricate our beams. We then need to transport them to a galvanising facility and have them hot dip galvanised, which uses a significant amount of raw materials and energy. We then need to transport that to site and construct it, and then we need to operate and maintain it. Typically, we might need to inspect or replace elements of those galvanised coatings every 25 years, particularly fasteners, which we can't get significant volumes of coating on. And there's also an associated cost there with access, safety, implications with providing safe access to that structure, and so on. In a recent case, we looked at a road bridge over rail. While it wasn't galvanised steel, it was over rail, and this access costs for inspecting that bridge were significant, to say the least. So if we can remove some of those requirements for inspection and maintenance, we can reduce the overall life cycle cost for that infrastructure asset. In the optimal case that we investigated in this particular case study, we looked at the use of weathering steel, which is an alloy steel designed specifically to to corrode and provide a protective patina over time that doesn't need painting or further coating. So by adopting weathering steel, we can essentially eliminate a complete construction process, eliminating effectively two transport legs and a large amount of energy and material inputs into the construction process. As an added benefit, weathering steel, because it doesn't need coatings that need inspecting on a regular basis, we should in theory be able to increase the time to first maintenance or time to first inspection by a factor of 3 times, which, when we look at the maintenance and access costs, that can have a significant cost saving over the life of that asset. But of course, selecting the weathering steel for use in infrastructure assets, whether it's bridges or facades or other infrastructure, there's a number of influences that we need to get right, and it really is in the detail. So not everyone likes the look of rusty steel, and it can be a little bit off-putting.
Hold on.
But then some people do. We need to consider things like access. So if we've got infrastructure going over large rail corridors or very busy highways or over very busy waterways, we need to consider whether that access is going to create a significant cost over the life cycle of that piece of infrastructure. We also need to consider the environment that we're building that infrastructure over. Weathering steel is not particularly happy when it's exposed to coastal environments, so weathering steel has its limitations in that regard. It really doesn't like to be in environments that are more close to the coast, and in that regard you might need to paint it if you were going to use it, so it sort of reduces the benefits. As I mentioned, aesthetics, the weathering steel, if it's not pre-weathered, can leave nasty staining, which New Yorkers found out when they put weathering steel on the Barclays Stadium in New York. It stained the pavement, and I think that's happened in a number of other cases around the world. But if it's properly weathered prior to installation, the patina is quite hardy and will hold on, and it's not really a big issue. Detailing. So, as with any steel structure, we need to make sure that we get the detailing right, and we don't provide significant areas or pockets where dirt can collect, or salt can collect, or rubbish can collect, and it needs to be relatively self-cleaning in that regard. And we need to make sure it's available. Weathering steel is only manufactured in a few countries around the world. It is manufactured here in Australia, and is available in selected sizes. But again, I think from my understanding, most of it is manufactured on the east coast here. So for the projects in Western Australia, we have that additional transport cost where it might be possibly more cost effective to bring down from Asia. But those are some of the limitations. When we looked at the overall costs implications of removing the galvanising, it's not a significant cost. I think for the particular bridge structure that we looked at, it was around about $80,000 of capital cost. But then I think we reduce overall CO2 emissions for that particular structure by about 1,000 metric tonnes compared to the base case of around 3,000 metric tonnes in terms of the initial construction emissions. But then again, there's the life cycle implications of having less access and less emissions associated with that access. So there you go. That's weathering steel versus galvanised steel. Thank you.
Thanks very much, Rob. And last but not least, Rayleigh, Director, Eco Barrier.
Hello. Oh, there we go. Look, I'm going to be talking today about noise control for construction works or maintenance works, when you're basically maintaining an asset. And with new innovations in this type of technology, there are new opportunities that are being created. So what I'd like to do is just cover a little bit of this. I'd like to talk about business as usual as how people previously treated noise. And there's really, the first option is no noise control at all, where basically we have the jackhammer going and everyone else basically gets hit with it. Secondly, we have situations where people put hoardings around the noise. And now we've got new innovations like Echo Barrier, which is basically a portable temporary noise barrier that can be erected when the noise is created. So you can basically try to control the noise at source. Now, the way I'm going to evaluate that is through build cost, sustainability, effectiveness, and then finally social license. Now, obviously, if you have no noise control at all, it can be potentially very painful for people, and people can get very annoyed by it very quickly. If you've ever walked past a live jackhammer, you probably understand why. Now, when I compare hoardings with Echo Barrier, basically in both situations there is still a design, build and remove process required for both. The difference is that the structural design of hoardings can take some time. It can be, in terms of I've got a video afterwards which I'll show you. Their examples run about a week to build a whole hoarding system around it. This thing was put together for this one example for 1 to 2 days, but you can actually just do it on temporary fencing and do it in a matter of hours. So it just depends on the nature of the noise source that you're trying to manage. And because when you're looking at noise, you've obviously got to look at your cost elements. You can either rent it for just the duration of the noise, or you can look at it as an enduring asset. And I guess that really plays to sustainability. Because it can become an asset, it can actually just sit as a continual thing that you deploy whenever you have situations where you have to interface with the community. With wood, typically, you don't typically try to reuse that. It's a bit hard to do, so you tend to throw it away. As a product, we actually have a design philosophy of actually trying to maintain a carbon neutral footprint. So we try to recycle as much as we can. Now, in terms of the effectiveness, I need to just turn this around a little bit. Hoardings typically work as a reflective noise management system. So basically, it bounces it around. Now, a lot of our projects are now being done in urban environments where there's a lot of reflective surfaces, roads, glass windows, all that can bounce noise around. I mean, if you walk around the city, your steps sound louder. And the problem is that noise is reflected everywhere. Our technology basically recognises that you need to be able to treat that through a different method, and we've used absorption technology as a way of being able to reduce it. And essentially, that's actually reduced. It basically soaks up the noise. Now, because of the design and the way that it's been put together, it was actually the core technology was actually done through some research with the London Underground, where they basically said, look, our trains stop at 1 a.m., our trains start at 5 a.m., we have a 4-hour window. So what work can we do? Everyone lives near train stations, so, when we do works, we don't have much time, so we can't stuff around. So they designed it to be very fast to install and remove, because you can't waste the time. Now, net impact of that, with hoardings, it's basically seen as just part of construction. Everyone just sees it as, oh, it's just part of, they're just building something there, and they just put this wood around it, and that's fine. They don't see it as being a way of reducing the noise impact on them. And, however, because of the bespoke nature of a branded barrier that actually has noise control system written on it, people have a different perception. They basically see that something is being done for me. And then they suddenly, the angst that people get changes. And it's all about communication and how people get communicated through the visuals of the system. Now, I'm going to go through and show you a video now of a project that we did. It was just in a suburb here in Sydney, up in Narrabeen. Yeah, let's go through that.
We're undertaking a horizontal directional drill from Weatherall Street, directly behind us, 800 metres south out into the Pacific Ocean. This drill is for Telstra, which is a telecommunications cable. It's called the Tasman Global Access System, which is linking Raglan in New Zealand to Sydney here in Australia. Not only has the eco barrier itself reduced the noise impact on the local residents, but it also closed our site, which stopped people from looking in, and also provided greater security on our site, and there's a clean, tidy presence on Wetherill Street, which is a very well-kept area. The little rig that's in the back of the site, it operates running at 1400 RPM. It gives off about 110 decibels to the side of it. They've recorded on the back corner of this site here, they've recorded 74 dB. So we know with the side of our rig being 110 standing beside it, to be 5 metres back and outside the barriers, we have a reduction of 35 decibels. So as far as we can say on this, has been a success. But we had a few residents recently going past the entrance of the site. When is the rock starting? Well, we are rocking. Oh, we expect it to be different bags of noises. That's it at its best.
I think he basically saw it in terms of the maximum potential noise versus what he measured. We actually got an independent test survey that showed it to be around about 20 decibels, so he's a little bit generous in terms of his numbers. Now, I've talked about the technology, what it can do. You can see how it's been used. What I would like to do is just talk about the new opportunities this type of technology can bring to projects and asset owners and project managers. First area I'd like to talk about is community relations. Now, often when they start a project, there is incredible angst in the community. You know, this no fun for locals type business published by the Manly Daily. I mean, they obviously have a lot of fear because they don't know what's going on. And from that, we went to a scenario where we did a post-implementation review, and people said, oh, well, you know, you've done a lot of consideration, and they felt treasured. They felt they were being treated properly. And, you know, you had the girl walking the dog as though it's like a normal day.
One more minute, Ray.
Yes. What we've learned through that is that there is more to it than just hanging the noise wall on a fence or a scaffolding system. It's actually 3 parts of the process. And this is something that we would like to explore with people in the community relations area to be able to discuss, because it's actually part of a process change. The first thing is, during the pre-works engagement, it's important that we actually reassure residents that something's going to be done for them. People just don't know about what's going to happen. And there is all this fear about, you know, there's no fun for locals. I'm complaining about sleep and all this. And the way that's being done is by showing them examples of where it's been done successfully before. You've got to reassure residents. And that's part of, you know, learning about other cases, which was, you know, whether something that we did in New York, like the World Trade Centre, or something we did in the UK with Crossrail, or something here in Sydney or Melbourne or whatever. That type of examples give people comfort. And then they basically, the angst level comes down. Secondly, as shown there, the visibility factor really does make a difference in terms of people saying, yeah, look, it's so much better than what we thought. Because their expectations are high, they see something's being done for them, and then the angst level just go down. And then finally, being responsive to complaints. You know, the old hotline number gets ringed up, you know, mate, you're destroying my kids, and then you know, they got uni tomorrow, they got an exam tomorrow, what are we going to do? If you can...
Ray, we're going to have to stop there, I'm afraid, so maybe people can ask you afterwards around the rest of the things, so apologies for that, but I'm getting a real significant message from over here. I'll be pulled off, not just you. So look, I'd like, again, thank everyone. I think 5 very different case studies. I think they were all winners, don't you? So please, a round of applause.